Good morning, students. In last class, we discussed the non-two-phase locking protocol, that is one non-two-phase locking protocol, that is graph-based protocol. Now today we discuss the timestamp based protocol. It is also non-two-phase locking protocol. Like graph-based protocol, this protocol also requires the prior knowledge about the ordering of data items in the transaction by a unique fixed timestamp, a time that will be given to a specific transaction, and uh, this time is known as timestamp. Now this timestamp is assigned by the database system before the transaction TI starts equation, and it will be denoted as TS of TI. If a transaction Ti has been assigned TS Ti, that is timestamp of Ti, and a new transaction Tj enters the system, then the timestamp of Tj is greater than timestamp of Ti. Now, at first, we implement the timestamp ordering protocol. For implementing the timestamp ordering protocol, we must know the two specific keywords. One is W timestamp and another is R timestamp. W timestamp stands for the write timestamp and timestamp stands for the read timestamp. Now W timestamp of Q, that is the largest timestamp for write Q operation successfully. Similarly, R timestamp Q means largest timestamp for read Q operation successfully. And the timestamp ordering protocol ensures that any conflicting read and write operations are executed in timestamp order. Now, how the protocol operates, now we see this. The first is, suppose a transaction Ty issue the read operation on the item Q, that is issue read Q. There will be two cases. The first one is if timestamp of Ti is less than write timestamp of Q. That means Ti needs to write a value of Q that was already overwritten, and hence the read operation is rejected and Ti is rolled back. Now for an example, let Ti has a timestamp at 4 p.m. and W timestamp of that value Q is 4.02 p.m. It means that if a transaction whose timestamp is 4 p.m. and want to read the data item who is already written by a transaction of timestamp 4.02 p.m. Thus, the request of read at 4 p.m. is rejected and Ti is rolled back. That means, suppose already an item write timestamp of an item is greater than greater than the timestamp of the read for a particular transaction Ti, then this read is not be successful and this read operation is rejected and Ti is rolled back. Now another case, if the read operation of the timestamp of the read operation by Ti is greater than or equal to the write timestamp of the item Q. That means the read operation is executed and the R timestamp of Q is set to the maximum of R timestamp Q, that is TSTI. Let the timestamp Ti is equal to 4.05 pm, that is the read Q operation of the timestamp will be 4.05 pm and the write timestamp of that Q will be 4.02 pm, and this read by the transaction Ti is executed and the read timestamp of that Q will be 4.05 pm. This is the first case. Now second case, suppose that transaction Ti issue write Q, that is write operation. Now there will be three defined cases. If timestamp of Ti less than R timestamp of Q, that means then the value of Q that Ti is producing was needed previously and the system assumed that value would never be produced. Hence the write operation by Ti is rejected and Ti is rolled back. That means whenever a write operation is required for Ti which is less timestamp than the read timestamp of Q, that is already read by another transaction the Q, the previous value of that Q, we can't write the operation and the write operation of the Ti is rejected and Ti is rolled back. For an example, let write operation of Q and the timestamp of Ti, that will be 3.58 pm and the read timestamp of that Q will be 4 pm. That means already read the data item in later. It means that Ti wants to write a data item which is already successfully read by transaction whose timestamp is higher than the write Q of Ti, and hence this write Q of Ti is rejected and Ti is rolled back. Now the second case, Ti want to issue write Q operation and the timestamp of Ti is less than the write timestamp of Q. Then Ti is attempting to write an obsolete value of Q. Hence write Q of Ti is rejected and Ti is rolled back. That means let the write Q operation timestamp by Ti is 3.58 pm and the W timestamp of Q, that is 4 pm. It means that is already written by higher timestamp transaction. So the write Q transaction of Ti is rejected and Ti is rolled back. That means it is already written by some another transaction. Then we can't write the transaction before that will be already written. So that will be rejected and Ti is rolled back. And the third case, if these two is not happen, that is otherwise, that means if timestamp of Ti greater than equals to read timestamp of Q or timestamp of Ti greater than equals to write timestamp of Q, then the write operation is executed and the write timestamp of Q will be the timestamp of Ti. Now for an example, let timestamp of Ti is equal to 4.05 pm and the read timestamp of Q will be 4 pm and write timestamp of Q will be 4.02 pm. Then the write operation of Ti is performed and the write timestamp of Q would be 4.05 pm. Now we consider an example. Here two transactions, one is T1, another is T2. T1 display the sum of A plus B and T2 will be transfer rupees 50 from B to A and then display. Now we consider the first schedule 1. Here T1 we assume that the timestamp of T1 will be 1 pm and the timestamp of T2 will be 1.02 pm. Now read B. So there will be no any other things. So read timestamp of B will be initially timestamp of T1, that will be 1 pm. Now for T2 read B. Since T2 read B, the timestamp of T2 will be the 1.02 greater than read timestamp of B. As per our this case, if timestamp of this greater than equals to write, no problem, read to read, there will be no any conflict. So that will be greater than and read timestamp of B will be 1.02. Then there will be some minus and write. Since write timestamp of B is greater than or equal to the timestamp of T2, that is here the timestamp of T2 will be 1.02, same. So write timestamp of B will be 1.02. So this operation will be performed. Now for T1 read timestamp of A, that will be the timestamp of T1, that will be 1 pm. Now for T2 read timestamp of A, that is timestamp of T2 greater than read timestamp of A, that is 1 pm. So it will be granted and read timestamp of A will be changes to 1.02. Now here display A plus B. Now for T2 A is equal to A plus 50 and write A. Since write timestamp of A is greater than equals to the read timestamp of A, that is 1.02. So that will be the write timestamp of A will be 1.02. And this schedule will be the concurrent schedule and that will be the consistent, because in both cases we get the value A plus B as same. Now we consider this schedule 2. In this case we get the different values of A plus B by T1 and A plus B by T2, and this result will be inconsistent. Now whether this schedule is satisfy the timestamp protocol, this schedule does not satisfy the timestamp protocol, because here the write timestamp of A is greater than the timestamp of T1. So this will be not permissible, not granted. And this T1 is rolled back. So this schedule 2 is not satisfied the timestamp ordering protocol. And this schedule is also the inconsistent. So again we just recap these things. Now timestamp based protocol same as graph based protocol, but there is some specific timestamp will be given for every transaction, and that will be unique. Here also we must know the prior knowledge of the ordering of data items like graph based protocol. In timestamp based protocol, all the transaction is assigned a timestamp before the transaction starts to execute. And if a transaction Tj is enters after the transaction Ti, then the timestamp of Tj is greater than timestamp of Ti. Now, how we implement the timestamp ordering protocol? There are two keywords. One is W timestamp of Q, that is the largest timestamp for write queue transaction successfully, and R timestamp Q, that is the largest timestamp for read queue transaction successfully. Now a transaction issue two things. One is read operation, another is write operation. Now if a transaction Ti issue a read operation, then how we can handle by timestamp ordering protocol? There will be two cases. If the timestamp of Ti is less than the write timestamp of Q, that means Ti needs to read a value of Q that was already overwritten. Hence this read operation is rejected and Ti is rolled back. Now for an example, suppose Ti has a timestamp of 4 pm and the write timestamp of the data item Q will be 4.02 pm. That means the timestamp of Ti for read the data item Q is less than the write timestamp of the data item Q. It means that if a transaction whose timestamp is 4 pm and want to read the data item who is already written by a transaction of timestamp 4.02 pm. Thus, this request of read operation is rejected and Ti is rolled back. Now the second case. Now if the timestamp of Ti is greater than or equal to the write timestamp of Q, then the read operation is performed and the write timestamp of the read timestamp of Q will set to the timestamp of TSTI. That is, let the timestamp of Ti is equal to 4.05 pm and the write timestamp of Q will be 4.02 pm. Then the read operation by Ti is executed and the read timestamp of Q will be 4.05 pm. So by this way we can implement the timestamp ordering protocol for read operation. Now we implement the timestamp ordering protocol for write operation. There will be three cases. The first case, if timestamp of Ti is less than read timestamp of Q, then the value of Q that Ti is producing was needed previously and the system assumed the value would never be produced. Hence the write operation by Ti is rejected and Ti is rolled back. That means if the write Q, the timestamp of the write Q by Ti, if less than the read timestamp of Q, that means the read operation of Q is already done later by any other transaction, then how we can write? So this will be not possible and Ti is rejected and Ti is rolled back. Now the second case, if the write operation of q by ti, that is the timestamp ti, is less than the write timestamp of q, that means ti is attempting to write an obsolete value of q. Hence the write q, timestamp, write q of ti, hence the write q of ti is rejected and ti is rolled back. That means if ti whose timestamp is less than the write timestamp of the data item q is less than, then the data item is already written by another transaction in future. Then how that will be all again retained by ti, and so this write operation is not execute and that will be rejected and ti is rolled back. And the third case is otherwise, that is if the write operation of q by the ti, that is the timestamp of ti, is greater than the read timestamp of q and the write timestamp of q, then the write operation is executed and the new write timestamp of q will be the timestamp of ti. Now here we see the timestamp ordering protocol for schedule 1, where T1 starts at 1 pm and T2 starts at 1.02 pm. So timestamp of T1 will be 1 and timestamp of T2 will be 1.02. Now for this read operation of by T1, and there will be no any such things, so read timestamp of B will be the timestamp of T1, that will be 1, and again the read operation of the data item B by T2, so the timestamp of T2 is greater than the read timestamp of B, so read timestamp of B will be the new value, that is the timestamp of T2, that is 1.02. Then B is equal to B minus 50 and then write. So the write timestamp of B will be the greater value of TS, greater value of the read timestamp. So that will be the timestamp of T2, that will be 1.02. Now for the read operation of the data item A, then read timestamp of A will be the timestamp of T1, that will be 1. Again the read the data item of A by T2, since the timestamp of T2 is greater than the read timestamp of A, so that will be execute and read timestamp of A will be 1.02. Display A plus B for T1, so we get the sum of A plus B, and then A is equal to A plus 50 for T2 and write operation of A. Since the write timestamp of A is equal to the timestamp of T2, so that will be 1.02 and that will be granted. And again we get the display of A plus B. The same result we get from T1 and T2. And this concurrent schedule under this timestamp based protocol or timestamp based schedule is consistent. But if we consider this schedule 2 and this schedule 2 is inconsistent and we get two different value of A plus B for T1 and A plus B for T2. But this schedule cannot satisfy the timestamp based protocol or timestamp based schedule. Why? Here the write timestamp of A will be 1.02 pm. Now TS T1 is less than the write timestamp of A. Therefore, this read operation is rejected and roll back the transaction T1. And there will be some drawbacks of timestamp ordering protocol. The drawbacks are each value stored in the database requires two additional timestamp fields. One field is for the last read and one field is for the last update. So the storage is huge. Another, it increases the memory requirements and the processing overhead of database. Since the storage is more, so memory requirement is also increases and processing overload of the database is also increase. So now from today, thank you.